Good morning, class. We're continuing with working with our processing platform. So the presentation materials are located on my website underneath your schedule. Again, it's shapes, variables, loops, functions, animations, and arrays. When we do get into that, it looks like this. And we are going to be on starting around slide 53, dealing with responses in processing. So we have a few different ways to handle responses. With a mouse response, you have various actions with your mouse or your cursor. You have an X and Y coordinates for where they are located currently. That's your mouse X and mouse Y. And we also have a P mouse X and a P mouse Y as to where they were located previously. So when we move, we have a new X and Y, but we also have a previous X and Y, and we can connect those two dots with a line or something of that nature. You have a mouse pressed, which is going to be a Boolean variable. Boolean variables hold only two values, either a true or a false. So if your mouse is pressed down, that would be a true or false statement, and then when it's released, it's the opposite. Okay, we have abilities to use your mouse button left, right, and center. So let's look at these examples, 5, 4, 5, 5, 6, 7, and 12. So in your processing program, remember our examples are going to be in there underneath File, Examples. So we're supposed to look at 5, 4, and 5, 5, 5, 6, I believe, and 5, 7, 5, 12. Okay, let's get a couple of these going right now at once so we can refer to them. So that's 4, 5, 6, 7, and 12. Let's go back and start with 4. Example 4. Let's run this. Okay, what is this going to do? So we're going to create an ellipse at mouse X and mouse Y. So wherever that cursor is going to be, you will draw an ellipse of a 9 by 9 size. So a diameter X and Y of 9 by 9. So what this is saying is that wherever that cursor is located, you're to draw an ellipse. So wherever my mouse and X and Y is. So let's look at 5, 5. Oh, that's 5, 12, sorry. Let's go to 5, 5. This, you can see we have a ball following our cursor. The way that that works is that your draw method, your setup method up here, your void setup is done once at the very beginning. However, your draw method is done every time that this program is rewritten, and that's very, very quickly, depending upon the clock timer that you have on your computer. But it's multiple turns per second. So what's happening is that we are drawing a background, that color, that 204, which is that kind of that gray. This 204 is that gray background. And so the first thing that is being drawn is the background, and then it draws your ellipse located at your X and Y coordinates of where your mouse is located. So the reason why we don't have the trail following us is that because every time we go back into the draw method, we start at the top, it colors the entire background with that color, grayish color, and then it draws your ellipse. And then when you move around again, it again draws the background color and then the ellipse. So what's happening is your history is basically being overwritten by that background. So we don't know where that ball has been. However, if I were to just simply to comment out that background, run that again, now we would have the program we just looked at on 5.5 where it traces and follows that ball. Okay, let's look at 5.6. Let's run this. Okay, this draws your line. Now this is not a what it's doing. If we look here at our coding, we have a previous mouse X and a current mouse X and a previous mouse X, and they're just connecting those two dots. So you're gonna have a line between wherever you exit it, and so like I have my previous one is gonna be at the top corner. If I came in over here, I see big jumps as I move around. Okay, so that's how you use that one. 5, 6, 5, 7. Okay, this is just a little bit different, so we can look here that, let's look at our code here. Pretty creative here. Well, the weight at which we are creating that stroke. So if we look here, very small movements are very small, large movements are large. So we can see that if the distance between those two values is high, then the stroke weight is a higher value. If the distance between those two are low, then that stroke weight becomes lower and that line becomes smaller. So really slow movements means that distance between those previous dots and the current dot is not large, and so the stroke weight is very small. If I make a big jump, that means that the distance between our previous and our current mouse X is large, so therefore that stroke weight will be large as well. Let's go 512. This is just a conditional if statement here. Basically, it's drawing a line. If the mouse is pressed, we have that line drawn. If the mouse is not pressed, it doesn't draw that line. So this line down here gets drawn if the mouse is pressed. Now we have, it looks like a mouse press left button. So if I press the left button, it's white. Else, it's going to be black. So on this one, when I right click, it's a black bar. When I left click, it's a white bar. So you can see that the mouse press is going to pick up your left or right cursor on your mouse. Okay, going back into our PowerPoint, see where we're at. Okay, examples for mouse demos. So we have these key responses like we just showed there. Let's look at 5, 18, 19, and 20 real fast. See what they've got for us there. 18, 19, and 20. All right, so let's look at 18 here. 5-18. We run that. These are key pressed. If key H is pressed, then we draw that line. If key N is pressed, we draw that line. So we can, and it's the character H. So you classify that with only one. It's not quotations, it's single quotes. So if we press the letter H, whether it be lowercase or capital K letter, it makes an H there. If I press the letter N, either upper or lowercase, it makes that other line and makes it N there. So that would be those conditional statements there. 518, let's look at 519. Run this. Okay, this is using your directional pad arrows, left and right. So basically it says if the left button is pressed, then my square is going to go left. If my key code is equal to right, which is the right arrow, then it's going to go that direction there. We don't have an up or down, just a left or right. So this I am controlling that animation using the left and right keys. Okay, continuing along with our work here, we're moving into animation. Animation requires the redrawing of an object or some sort of a coding over and over again. Your setup feature is only invoked once at the very beginning. However, your draw function is invoked repeatedly to simulate animation. So your draw feature goes over and over and over again, whereas your setup feature is only done one particular time. So this here is just saying, okay, my fill color is going to change based on where my mouse is located. But we can see that this draw method is being redone over and over again. If I copy and paste this code into just an example here, we can get a sketch maybe. Run this here. So you can see that where my mouse X and Y is located determines what color that ellipse is being drawn at. So that's kind of a cool example there too. Not a lot about animation. Animation has to deal with speed and direction, so we have to see how fast we're going and in what direction we were going to be moving to. So let's look at 8.3 and 8.4 real quick. Let me close some of these out. All right, let's look at 8.3 and 8.4. Okay, run 8.3 first and see what it does. Okay, so we have here an arc which is going in where the x value, the x coordinate is increasing, and then it just goes off the window, continuing off into Never Never Land. If I increase the size of that window, it would continue to go out there out to the right. So what we're using here is a variable called speed, and it is set at a 0.5. So every time that this draw method is called, again, many times per second, speed is going to be 0.5, but we are adding that to x. So this is saying x is equal to x plus speed. So another way of looking at this, the exact same code here, and without using shorthand, is going to say x equals x plus speed. That's the same thing as what is listed right before. X equals x plus speed. So that is, these two lines are the exact same. So if I ran this, I'm imagining right now, I don't know what's going to happen. It'll probably move twice as fast. It's moving a little bit quicker again. Okay, so this line of code is unnecessary. That's how we are manipulating that. So x, every time this is drawn, x is going up by 0.5. So if we want to make this move faster, we can make it to 1. Now x is going to move twice as fast. It's going to increase by 1. If I want to make it really fast, I maybe make it 10. Now my speed should be updating quite a bit, and now we're cruising. Okay, so that's how you manipulate an object to move to the right. We just increase the value of the x coordinate by a certain amount. So you create a variable called speed. You create this little line here where x is equal to x plus speed. Then you draw your object where x is being referenced, the line above it, every time this draw method goes. Okay, now let's see what happens with this one here. We have our Pac-Man moving. And then it restarts at the very beginning. Okay, let's look at how that is done. That's fantastic animation there. So we have our speed, so it is manipulating that x. And it says here, if x becomes greater than width plus radius, then x is going to equal a negative radius. So that would mean that it moves it, then the x value jumps all the way back down to a negative radius, where that would move it to the left edge here. So let's watch this as this takes place. I'm going to do a print line for the value of x here, and watch how x increases, sorry. Okay, so I'm going to run x. I'm going to run this program with a print value of x. Now, watching as this gets closer to the right side, what value of x is, and then watch how that changes. Okay. So what happened is once x hit a certain value, then it changed on us all of a sudden. So let's take a look at what happened there. Okay, so x, once it hit 280.5, it jumped down to basically like a negative 39.5, which would be close to a negative 40. So let's look at our code here. That's what happened there when it bounced back to 40. It went to a negative 40. So radius became, x became a new negative 40. And so that pushed it way back to the far left-hand side of that animation window. So if we look here, once it hit 280, so width plus radius. The width of the window is 240 and radius is 40. So that makes 280. 40 and 240 is 280. And so once it got to 280, it said here, if x becomes greater than 280, then we put x, which is drawing this arc, back at like negative 40, and then it just starts over again. And so it's using this conditional statement, checking to see where it meets the far right-hand side, and then once it does, it reestablishes where x is being drawn. X is now being drawn in this arc way back at the very far left-hand side of that animation window. Okay. So what we need to do now is we want to try to modify that so that it bounces back and forth between those two walls. Okay, so we're going to modify this a little bit, this code here, so that it's going to bounce back and forth. What I need to do now, though, is set up a few variables above the very beginning. We have ourselves a speed, radius, x, float, speed, and I need to have now a direction. And I'm going to just have it has a value of 1 right now. This is going to help me manipulate that Pac-Man to change directions and start looking or moving to the left. So in our draw method, after we have our draw method, we have our background being updated right here. We're going to say x is actually going to be speed times direction. So any value times a positive, well, so we have speed, at this point in time, speed is a 0.5, direction is a 1. This direction, we are going to flip its value being positive and negative and timesing it by speed. So that should give us a way to reverse the direction. If direction is a positive one, we're going to increase the value of x and move to the right. If direction is a negative one, we're going to times that by speed. It will be a negative value, and that will attribute to x, and it will move it to the left. So we have that. Let's just do our parameters. If we are within the radius, width plus radius. Now, this is another symbol that we want to know a little more about. This is the and symbol. So this is a dual condition. So both of these need to be met. And if x is also going to be less than radius, those two conditions, what we're going to do then at that point in time, we are going to use direction and flip it. We're not going to do anything with this x right here. We're going to delete this line here, and we're going to flip directions. If direction is okay, so basically, if we get too far to the right, or if we get too far to the left, so if x becomes too large, or if x is too little, then we are going to flip the value of direction. So this is just flipping it from positive to negative, both ways. It can go from negative to positive and positive from negative with this here. Okay, now in here, we're going to do some if conditions. If direction is 1, uh-oh, did some problem there. If direction equals 1, then we're going to draw this arc. Else, We're going to draw a different arc, which is facing the other direction, so that we can see our Pac-Man face the other way. This here should face right, and this one should face left. Made a little bit of an error there. Let's go back and look through what I've done here. Oh, sorry. I needed to make some more parentheses in here. Let me pause this real quick to see. I needed to change the initial value for our x to drawing those arcs. So let's make float x equal to, like, say 110. That'll give us a better starting position so we can see our Pac-Man. That was the only correction I needed to make on this. So our Pac-Man, once it starts exiting that window, then it should flip around and come back, and you can see that the mouth is faced to the direction. And it flips back and forth doing that. Okay, so now we have a Pac-Man bouncing back and forth between these two windows. What I would suggest, though, as one of the parameters to help this make a little bit smoother is to say, let's see if I minus the radius on that. That looks a little bit smoother. That way that when it kisses either edge, it turns around, and we have ourselves a nice animated Pac-Man. Okay, so here's a couple more examples here. I'm going to give these examples to you, these Ruba variables. I've got these and I'm going to put them in as an attachment, but let's take a look at these real quick. So we have our Ruba animated. So this is that robot that we made the other day, and here is its animation. So all that code is from our Ruba variables, and all that I have done here is added in this little bit of code right here. So if, for instance, we just want the Ruba to bounce off of the horizontal axis, we're going to be manipulating this right here. This is center x is going to equal center x plus a shift. So I'm going to have a shift here, a shift value. This is kind of like speed. I would say it's the same type of principle, that we're shifting or that we have a speed in a certain direction. So I have these two variables here, shift x and shift y. These are going to be used to help manipulate that Ruba, because our question was to say that we need to have it bounce back and forth from the x-axis, y-axis, and then in all directions. So right here, we look at our center x is going to be equal to what it was plus the shift x. And now then, that shift is going to be like your speed and direction. It's going to be changing its value. So if our x value is going to be the width of the robot minus the width of the screen minus the width of the robot, so it's at the very edge but still showing, we're going to shift the value of x. That means that it goes back in here, and that means that now the center x, which draws all of these features, is going to be getting smaller. it was getting larger, then it's going to be getting smaller. And then if that x's only value is only the width of the body, so if the body is on the far left-hand side and that's where that x value is, then again we're going to shift this in the other direction. So let's run this. So, and that's our speed. Our little guy is bouncing back and forth between the two windows there, or between the left and right sides of your window. Now, if I want to comment this out, now I've just gotten rid of the center X shift and now I'm dealing with the center Y shift. It should bounce the Aruba up and down. Okay, great. Now, if you want the Aruba to be going in all directions, you just do both shifts. Shift at center X and shift at center Y. So now when we've removed all our, now then that Aruba is going in all directions. And I will give you this Aruba animated code for you to load and to work on, to look at. So this is going to be your assignment. It is a large one. We're going to be dealing with this animated yin-yang. Now the assignment, your assignment specifications will be located on your BSU site here underneath assignments. If you scroll down here, you'll see on week 6 we have our yin-yang sketch. Let's take a look at that real quick. Okay, so we've done a lot of this already. You should have pre-built a yin-yang, and we have used variables as well to refactor it. If you haven't, then that is part of what this assignment is going to be helping you with. So the first spec or specification, for 20 points, you're going to draw your yin-yang. You should have done this already. Make sure that your window is 400 by 400, so size is 400 by 400, and the yin-yang, its diameter is 200 by 200. Second point on our specifications, worth 15 points, is to use variables to refactor the previous sketch such that the yin-yang symbol is drawn relative to one point, for example, the center or the top left corner. So just make sure that if I adjust the window size, that your yin-yang is in view. So if I blow up the window and I make the height really, really large, I'm still able to see that yin-yang maybe starting at the same relative point to maybe the top left, maybe this top left corner or the center, somewhere where it will begin. When you are refactoring this, it does not mean that that yin-yang will grow or shrink based on the window size. The yin-yang itself will remain the same size despite the window size. Okay, point 3, worth 15 points. We need to adjust the window size to make it 800 by 400 and then animate the yin-yang so that it is moving left and right until it touches the edges. And then it should reverse and do the opposite. If you need some hints on this, check example 8.5 from your processing book. So it should just touch the edge. The edge of the yin-yang should touch the edge of your window, the animated window, and then it should reverse. So then the left edge of the yin-yang is touching the left side of the window and reversing back and forth. Okay, extra credit. This is worth 10 points. It is making the yin-yang roll along its center. You'll need to use trigonometric functions, sine and cosine, to calculate the coordinates of the center in small circles. The processing functions are named sine and cosine, and they take in angles and radians. To use degrees, use radians functions. For example, sine radians 180. Now, you might want to reference back to your handout, the PowerPoint presentation, and there's some information here, animated sine waves. examples, basic math sine waves, and polar to Cartesian. So both of those could be very helpful with this extra credit piece. Again, when you're finished, create a tab in your portfolio. Under homework, name it yin yang. Do a little write-up describing how you implemented the variations and what problems you had along the way. You can include the .pde processing file to your page, or simply cut and paste the processing code on the homework page so that I can run it. That is your main assignment for this week and the wrapping up of week 6.